Welcome to this lesson on the law of sines, the ambiguous case. When you're given two sides and an angle, so side-side angle, it is called an ambiguous case. The reason is because there can be more than one outcome. So let's look at three possible cases here. The first case is when the side opposite the given angle, so what I mean is, here's my given angle, 62 degrees. Here's its corresponding side, the side opposite of it. It is greater than the other side that we're given, which is 9. So 12 is greater than 9. All right, when that happens, there's just going to be one triangle, which basically means it's going to be like the examples we did in the previous video. It's just going to be a normal law of sines. Set it up. Only one triangle is going to be an option. So I can set up 12 over sine of 62 equals 9 over the sine of x. And I can solve like normal. The only difference in these is I have an angle I'm solving for, so we're going to have to use the inverse sign at the end. But I'm going to start by cross multiplying, just like any proportion. So sine of x times 12 is 12 sine of x. Sine of 62 times 9, I'm going to multiply that in my calculator. That's 7.94. 95 if we round, but I'm just going to leave it in my calculator to get the most accurate answer. And then I'm going to divide both sides by 12. And then use the inverse sign to solve for that angle. And I get about 41.5 degrees. So that means this angle here is 41.5 degrees. That's the only triangle that can be formed with that angle and those two sides. And we're done. Case number 2 is where the side opposite the given angle, so here's my given angle, here's the side opposite of it, it's less than the other side that we're given. So 9 is less than 14. All right, so let's go ahead and set up like normal and see what happens. 9 over the sine of 53 equals 14 over the sine of x. So 9 sine of x, I'm going to multiply in my calculator, sine of 53 times 14, 11.18. Divide by 9. So now I have the sine of x equals 1.24. I'm going to have to use the inverse sign to solve for that angle. And when you do that in your calculator, it's going to say domain error or error. The reason is because you can't take the sign of a number greater than 1. It's not in the domain of sine. So when that happens, that means that no triangle can actually be formed using this angle and those two sides. It's not possible to have a triangle with those. All right, so that's case number 2. Case number 3 is similar to case number 2 because the side opposite the given angle, so here's my given angle, here's the side opposite of it, it's less than the other side. 5 is less than 9. But in this case, it is going to form a triangle. So let's see what happens. So 5 over the sine of 33 equals 9 over the sine of x. All right, I'm going to cross multiply here. So 5 sine of x equals sine of 33 times 9 is 4.90. I'm going to divide both sides by 5. I'm going to bring it over here so I have more room. So about 0.98. Take the inverse of that. And I get about 78.6 degrees. But if you look at the picture over here, the diagram, this is obviously an obtuse angle greater than 90, so it can't be 78.6 degrees with that picture. Now, if you look at the triangle below, this could be 78.6, and it actually is. So let's talk about why. The sine of an obtuse angle is equal to the sine of the supplement of that angle, meaning whatever angle adds up to 180. There is another option for the triangle. So actually, given this angle 33 degrees and those two side lengths, two triangles can be formed, not just one. And you can even test this out. So I'm going to find the supplement of 78.6. So I'm going to subtract from 180. And I get 101.4 degrees. So this angle up here, this obtuse angle, is actually 101.4. So both of those angles work. And you can even test this out. So the sine of 78.6 degrees and the sine of 101.4 degrees. They're both going to give you about 0.98. They're equal to each other. So when that happens, that means there are two possible triangles. All right, so let's look a little bit further. So let's fill in this chart just so we know. And make sure that you have side-side angle for the ambiguous case. So for no triangles, you're going to be looking for the side opposite the given angle. I'm just going to put OPP for opposite. Is less than the other side that you're given. And you're going to be looking for that domain error in your calculator, or error. For one triangle, the side opposite the given angle is greater than the other side. And then for two triangles, the side opposite the given angle is less than the other side, but there will be no domain error. It's going to actually give you an answer. So these two go together. They're going to have the same beginning, but the domain error is going to tell you whether there is no triangle or one triangle formed. So let's look at some examples here, and I'm going to try to draw these out. That's going to help you. So let's see, I'm going to draw a 100-degree angle the best I can. So side A is 29. That's going to be the side opposite of angle A here. And then I'm just going to call this B and this C. So this would be 33. It's opposite of angle B. So usually with the ambiguous case, it's going to ask you how many triangles can be formed, 1, 2, or 3. So in order to determine that, first we need to determine, is the side opposite the given angle less than or greater than the other side given. So here's my given angle, 100 degrees. Here's the side opposite of it, 29. 29 is less than the other side, 33, which means either no triangle can be formed using these, or two triangles can be formed using this angle and these side lengths. So to determine that, you're going to set up the law of sines. So 29 over the sine of 100 equals 33 over the sine of B, angle B. And I'm going to try to solve for angle B. And remember, you're looking for domain error or no domain error. So I'm going to cross multiply here. About 5. Divide. And then to solve for angle B, we would use the inverse sign. And because that number is greater than 1, that's going to be a domain error. So that means no triangle can actually be formed using that 100-degree angle and those two side lengths. All right, let's try number 2. So I'm going to draw this the best I can. All right. So I am going to set up, first of all, let's see. This is my given angle. Here's the side opposite of it, 13. That's less than 15. So we're either going to have no triangles or 2 triangles. So I'm going to set up my law of sines. Let me get this purple color again. So 13 over the sine of 41 equals 15 over the sine of A. And let's see if we can solve for A. All right, so 13 sine A (9.8) divide by 13 on both sides. And then to solve for A, I would need the inverse sign, which gives me about 49.2 degrees. So because I was able to actually find an angle, that means there are 2 possible triangles here. And I know there are 2 because this right here. The side across from the given angle is less than the other side. And the 2 possible triangles would be 49.2 degrees for A, or the supplement of that, 130.8 degrees for A. Both of those would work in this case. All right, you can go ahead and stop the video now and complete your practice.